Hello class, this is the notes for section 8.4 for Algebra 2 Trig. We've been talking about multiplying and dividing by irrational or with rational expressions. Here in this section 8.4 we're talking about adding and subtracting rational expressions. So really we're talking about adding and subtracting fractions. As you know, in order to add or subtract fractions you have to have the common denominators. And once you do have the common denominators, then you just add or subtract the numerators. And so that's what we're looking at for these first two examples here. We're adding these two fractions. The x plus 7s are the denominators. They are the same. So when you add them, that is your denominator. We're not going to have two of them. That's the one denominator. And then we're adding our numerators. And so what we get is 11x over x plus 7. There are no common factors to simplify, so that's it for that problem. Same idea for this second example. The x minus 4s are the denominators. They are the same, and so we're going to keep that denominator of x minus 4. Then we have our numerators that we'll subtract. So 7x minus the second denominator, and especially with subtraction, make sure you're using parentheses, because what we're doing is subtracting each of those terms, the 4x and the 12. So 7x minus 4x is 3x. We are then subtracting the 12, which is x minus 4. Now, once you get that into a single fraction, you always need to look to simplify. In that numerator, there is a factor of 3. You factor that out, you got x minus 4 over x minus 4. Those x minus 4s cancel out. We are left with 3 for that answer. Okay? So, common denominators are already there, not a big deal. If you don't have common denominators, then you got to get them. So to help get them, it's nice just to write all the factors that you have in your denominators. X plus 6 is a factor. You factor that x squared minus 36. That's x plus 6 and x minus 6. Okay. You always want to be dealing with the least common denominator. LCD is a phrase you might see sometimes, with the smallest common denominator that is possible. So both of these denominators, they already have an x plus 6. So we don't need to keep on multiplying by another x plus 6. We've already got that in common in both denominators. What's missing in this first fraction is the factor of x minus 6. So let me move this over a little bit. So we need to do for this problem is get this first fraction to have that x minus 6 factor in the denominator. So if we do this multiplication just in the first fraction, what that's going to give us is x minus 6 times x in the numerator, and then we got x minus 6 times x plus 6 for the denominator. We're adding that to the 72 over x plus 6, x minus 6. Okay, if you look at this, now we got common denominators. So our least common denominator, it is that x minus 6 times x plus 6, or x squared minus 36 if we put them together. All right, so we're always looking for the smallest common denominator, least common denominator is the proper phrase. And you look at the factors. You got each denominator has to have the same factors. Some of them already have the common factor, so we don't need to deal with it anymore. We just need to get the other factors to be in all the denominators. So what we're looking at here, this is x squared minus 6x. We're going to add that to 72 over x squared minus... I'm going to leave them as the factors. It's looking like we might be able to cancel some things out. You could put it as the x squared minus 36, but again, you may be able to factor it later on. So does this numerator factor? 8 and 9 is a factor of 72, 12 and 6, but the numbers don't work right, do they? No, they're not working right. So this is it. X squared minus 6x plus 72 over x squared minus 36. That is as good as it's going to get with this one. still looking at that as factoring. Well, it looks like it's factors, but I don't think it does. If it does, then let me know in class tomorrow. But this is the idea of these problems. Okay, so now looking at this problem. That x squared minus 1 has nothing to do with 3. It is factors to x plus 1, x minus 1. So clearly we don't have common denominators. So looking at that first denominator, the 3x minus 3, there's a factor of 3. You factor that out, you're left with x minus 1. So what's in common already in our denominators is the x minus 1s. What we need to have for our common denominator is all of these factors. So we need to have a 3. We need to have the x minus 1, which both of them already have. And we need to have that x plus 1 also. So in that first denominator, what we're missing is the factor of x plus 1. So we're going to multiply that first fraction, top and bottom, by x plus 1. Minus. What's missing in the second denominator is the factor of 3. So top and bottom by 3. Okay, so what we have now, if we multiply this first fraction, x squared plus x, that will be over, and we'll put this into the fully factored form, x plus 1, x minus 1, minus 3x over 3, x plus 1, x minus 1. Again, I'm putting in factored form the denominator just in case some things do cancel out. Okay, so now we've got our common denominators. This 3 times x plus 1 times x minus 1, that's our least common denominator. We're going to subtract our numerators. So x squared plus x minus a 3x is a minus 2x. That is over 3, x plus 1, x minus 1. In the numerator, there is a common factor of x, but we're left with x minus 2, so there is no common factors. So let's just clean things up a little bit. That is x squared minus 2x over 3x squared minus 3. That is our final answer. Okay, so it's, again, there's a lot of factoring involved here, but now in order to add or subtract the fractions, you're trying to get that common denominator, or at least you have to get that common denominator, and then combining your numerators, and then looking to simplify. So that's it for this part. There was another example that it gets a little bit more complicated with some more fractions inside of the fractions. We'll talk about that first thing in class. Have a good night.